Neural networks are getting really popular nowadays because of the increase in big data, and it helped in improving every major industry. It is being used nowadays in mostly every research and project. So today we are going to build a neural network in just 5 minutes. So there are three steps involved in every machine learning model: build the model, train the model, and test the model. So first of all, after building the model, we train it by providing the data sets of inputs and outputs to help it recognize the pattern. And to help it recognize the pattern more precisely, we give it more data. So let's build a basic three-layer neural network model in Python. So first of all, we are going to import NumPy, which is a library for scientific computing. Then we are going to create a function that will map any value to a value between 0 and 1, which is called a sigmoid, and it will run in every neuron of our network when data hits it. I named it prob here because we'll use it for creating probabilities out of numbers. It takes two parameters, the x and d. X can be anything, and this d is a boolean, which is false by default. So if we mention it true in the second parameter when we are calling this function prob, then it will return this value. Otherwise, it will return this value. Now let's initialize our input dataset as a matrix where a row represents a training example and a column represents a neuron. Here we have three columns in each row, which means we have three input neurons, and these four rows means we give four different input datasets. Now this is the output dataset, and we'll create a seed function here for generating random numbers to make it deterministic. By providing seed, we ensure to get the same numbers each time when we run our program, which helps in debugging. Now we'll create synapses matrices. Synapses means the same here. What does it mean in our nervous system? It connects neurons. Connections are made between the neurons of first layer to every neuron of the next layer. Since we have three layers in our network, we need two synapses matrices. Each synapse has a random weight aligned to it. Now after this, we'll train the model. For this purpose, we'll use a for loop that iterates over the training code to optimize the network for the given data set. We will start up by creating our first layer. It's just our input data. And then to create the second layer, we are going to perform matrix multiplication on layer 1 and its synapses through this dot function of numpy. And then we are going to perform sigmoid function, and I named it here prob, on all the values of matrix. Now this layer contains the prediction of the output data. Now for our next layer L3, we are doing the same with the second layer to get and its synapses to get the third layer L3. Now here L3 is more refined prediction than L2. Now let's compare it to the output data using subtraction to get the error rate. Now we are going to print out the average error rate at interval of 10,000 to find out if it really goes down every time. And then after that we will multiply our error rate by the result of our sigmoid function. This function is used to get the derivative of our output prediction from layer 3. This will give us a delta which we will use to reduce the error rate of our prediction when we update our synapses every iteration, right over here. Then I want to see how much layer 2 contributed to the error in layer 3. We'll get this error by multiplying layer 3's delta by synapse 2's transpose. Then we'll get layer 2's delta by multiplying its error to the sigmoid function, the result of our sigmoid function. The function is used here to get the derivative of layer 2. Now that we have deltas for each of our layers, we can use them to update our synapse rates, reduce the error more and more every iteration. This algorithm is called gradient descent, and to do this we will just multiply each layer by a delta. Finally, we'll print the predicted output. Let's check out how it works. So I'll run this code in terminal, and I put it on desktop, and I name this file NNN, so Python networks.py. You can see the error rate is decreasing every iteration, and the predicted output is very close to the real one. So this was just a very basic three layers neural network, and there is so much to improve it, and I'll talk about that in my later videos.